Okay, here's chapter 1.4, solving linear systems. The essential question to this chapter is, how can you determine the number of solutions of a linear system? A linear system is consistent when it has at least one solution. A linear system is inconsistent when it has no solution. What you will learn in this chapter is to visualize solutions of systems of linear equations in three variables. Three variables? What? Solve systems of linear equations in three variables algebraically, and solve real-life problems. Okay, so the core concept in solving a three-variable system is step one, rewrite the linear system in three variables as a linear system in two variables by using the substitution or elimination method. We'll get to that. Step two, solve the new linear system for both of its variables. And then three is substitute the variables found in step two into one of the original equations to solve for the remaining variable. Sounds like a lot, but it's actually not too difficult. When you obtain a false equation, such as a number 0 equal to a different number 1, we obviously know 0 does not equal 1. When that happens, that means the system has no solution. So if we get to a system and we finish and it says all the variables cancel and you get 5 equals 13, no solution. When you do not obtain a false equation, but obtain an identity such as 0 equals 0, 3 equals 3, 4 equals 4, then the system has infinitely many solutions. And we would say that the two linear equations would coincide. They sit on top of each other. And that's what we'll be doing from here on out. Okay, so example one, solving a three variable system in one where we will get one solution. Okay, so there's a possibility of one solution, two solutions, or three solutions. And they give a diagram example visualizing the solution of systems on page 30. I'm not going to go over that. That's just for your review. So let's start out here by solving this system. And this is going to come out to one solution. So what you do is we have three equations here. The first thing I always look at when I am trying to solve a problem is, are there any matching coefficients? Okay, the term in front of the variable. So 4 and 2 and 6 are all different. Nothing matches. So then I move over to the next group and I look at the y's. I have a 2, I have a 3, I have a 1. Nothing matches. Then I come over to the z's and I have a 3, I have a 5, I have a 4. Nothing matches. If they did match, we would just simply take the two that matched and use those two to reduce down to two variables. But since I don't have any that match, I can use any combination of these three and eliminate something. What I'm going to do is I'm going to take the first equation, which is 4x plus 2y plus 3z, and I could use this one here, but the book used this, so I'll follow what the book did. It does not matter. We're going to work with these two. So what did I just choose? This is equation 1. This is equation 2. And this is equation 3. So the first thing I'm going to do is work with 1 and 3. And I look at the y's. And in order to get a 2, I need to multiply this 1 that's here by 2. So I'm going to multiply this equation by 2. And that is going to yield new equations. So a new equation. So what it's going to do is I'm not going to change the 4x plus 2y plus 3z. So I'm just going to bring that over. Okay. But then I need to do the distributive property and do a multiple of this one. So 2 times 6 is 12x. Okay. I almost put a plus there. It is not plus. Watch your signs. And 2 times a negative 1 is negative 2y. And 2 times 4z is 8z. Equals, and you need to multiply the constant on the other side as well, and that is negative 6. Okay, so now that you see that I have opposites here. When they are opposite, you add the two equations. So 4x plus 12x is 16x. 2y plus a negative 2y cancels, they're gone. 3z plus 8z is 11z. And that equals 12 plus a negative 6, which is 6. Okay, so I got an equation and there's no y's. There's an x and there's a z. Great. Now what we're going to do is we're going to, let's see, I'm trying to just use the two equations that the book used. And so then the book goes to, they use 16x plus 11z. And what other equation are they using? Okay, they use 2 and 3. So I'm going to use 2 and 3 as well. So they are taking this equation and this equation and trying to eliminate the y. Okay, we're trying to eliminate the same variable we eliminated here. So we have two equations with x and z. So I want to get rid of the y here. Don't multiply something over here and get rid of an x, and then I have an equation with yz and an equation with xz. You want to eliminate the same variable in both. So I want to get rid of the y. Well, what do I multiply 1 by to get 3? And the answer to that is 3. And I want the sign, it doesn't matter what sign, the book multiplied by -3, I'm going to do it this way to show you what happens. So again, these are going to carry over, and my 2x plus 3y or minus 3y plus 5z does not change. So I'll bring that over. This just moved over to here, and I distribute 3 times 6x is 18x. 3 times a -1y is -3y. 3 times 4 is 12z. And 3 times a -3 is -9. All right. And now I'm not going to add because these are the same. I am going to subtract. 2x minus 18x is -16x. -3y minus a -3y is plus 3y, cancels. 5z minus 12z is -7z. And that equals -7 minus a -9, which is +9, will give me 2. Okay? Okay, so now what I want to do, so let's recap this. Over here, I used equations 1 and 3, multiplied 1 by a value to get the y's to be opposite, combined them, eliminated y. Then I took equations 2 and 3 and combined them after multiplying the bottom one by 3 to get the y's to cancel there. So now I have two equations where there are no y's. So I am going to now solve for these two. So what I'm going to do is I'm going to combine these. 16, and these are opposites, so all I need to do is add. 16x plus a -16x is 0. 11z plus a -7z is 4z. 6 plus 2 equals 8. Divide both sides by 4. The 4's cancel, and I found z. Z equals 2. So my goal in this is to find what x is, find out what y is, and find out what z is. And I already found z. Z is 2. Okay? So then what I do is I then take an equation and substitute in that z. So let me see what equation to use. I can either use one of the two new equations that I've created. I will use this one. Okay, it doesn't matter which one you use. So I'm taking 16x plus 11z, and I'm going to rewrite it. And then I substitute in my 2 for my z, and that will find x for me. So it's going to be 16x plus 11, and I know z is 2. And that has to equal 6. So simplifying that, I get 16x plus 22 equals 6. Subtract 22 from both sides, and I'm going to get 16x equals -16. 6 minus 22 is negative 16. Divide by 16 on both sides. And I get x equals a negative divided by a positive is negative. 16 divided by 16 is 1. X is negative 1. Okay. Now what I can do is I can take one of the original equations, substitute in the z and the x, and find y. So let me use this equation again. So I'll take my original 4x plus 2y plus 3z equals 12, and I'll substitute in. So I'm going to take, let me use a purple now, 4, my x is negative 1, plus 2y, plus 3, and my z is 2. And that equals 12. 4 times negative 1 is negative 4, plus 2y, plus 3 times 2 is 6, equals 12. Combining like terms, negative 4 plus 6 is 2, so I get 2y plus 2 equals 12. Subtract 2, and I get 2y equals 10. Divide by 2, y equals 5. Okay, so I found y to be 5. So here are my 3 variable values. Before I confirm this, I want to check it in any one of these 3 equations. And I will use this one. It doesn't matter which one you use. You can use any one of the 3. I will use the second equation to check. So now I'm going to check my solutions. X equals negative 1, y equals 5, z equals 2. This has to be true for all 3, but I'll just check the 1. So 2 times negative 1 minus 3 times 5 plus 5 times 2 has to equal negative 7. 2 times negative 1 is negative 2, minus 3 times 5 is 15, plus 5 times 2 is 10, equals negative 7. Negative 2 minus 15 is negative 17. Negative 17 plus 10 is, in fact, negative 7. And I got negative 7 equals negative 7. That is true. So my solution to this equation is negative 1. Actually, let me explain that first because it's probably new to you having a z variable. Remember when we have ordered pairs? It's x comma y. For example, if I had the point 3 comma 2, then you'd go right on the x-axis 3, up on the y-axis 2, and put a dot. Okay, now we're going 3-dimensional and we're going z. We're going left, up, and then out into space, if you will. And I'll explain that better in class. But we now have an ordered pair with x, y, and z. Okay, and substituting these values in, my answer would look like this. Negative 1, y was 5, z was 2, in parentheses. So the actual answer is right here. And that's the format you would write it. So the answer to this system is negative 1, 5, 2. Okay, example 2 is solving a 3-variable system, and we're going to get no solution. So solve the system, it says. So the first thing we do is we take the first 2 equations and rewrite them. So I'm going to bring this down here, make a copy, bring this down here, and bring this down here. Now, when I look at these, I see that in order to get the x's to equal, I need to multiply the top equation by 5. So I'm going to multiply this one by distributing and getting 5 times x is 5x, 5 times y is 5y, plus 5 times z is 5z, and 5 times 2 is 10. I'm not going to change the second equation, so let me just bring that over from here actually and line this up like so. and then I'm going to either add or subtract. When your two coefficients are equal, you subtract. Anything minus itself is 0. When they're opposites, you add, because adding opposites gives you 0. So 5x minus 5x is 0. 5y minus 5y is 0. 5z minus 5z is 0. 10 minus 3 is 7. So that's going to give me 7 over here. And 0 plus 0 plus 0 is 0. 0 does not equal 7. That is false. So therefore, no solution. So we are done right there. As soon as you get variables to cancel and you get a number equal to a number, you are done there. And if those numbers are not equal, there is no solution. Okay, example 3, solving a 3-variable system with many solutions. Okay, so again, we're going to take the first 2 equations and we're going to just bring them down and recopy. Whoops. Okay, there's the first 2 equations. And as I can see right now, if I just add them, the z's will cancel. Okay, so I'm going to add those. So x plus x equals 2x. Negative y plus a negative y equals negative 2y. Z plus a negative z is 0. Negative 3 plus negative 3 is negative 6. Okay, so I get 2x minus 2y equals negative 6. Now I'm going to take the second 2 equations, this one, and let me change colors here. It's going to be these 2 equations this time. So I'm going to use these 2 and put them together. Now when I look at these, I see the z's are opposite, so I don't have to multiply anything. I can just simply, since they're opposites, I can add. X plus 5x is 6x. Negative y plus a negative 5y is negative 6y. Negative z plus z is 0. Negative 3 plus a negative 15 is negative 18. So I get 6x plus 6y equals negative 18, and 2x minus 2y equals negative 6. Okay, so now what we're going to do is we're going to take our 2 new equations. Let's do it over here. Take our 2 new equations and combine them. And then I take a look at them. I'm going to have to manipulate these somewhat. There are no opposites or equals. 2 does not equal 6. 2 does not equal 6. So I'm going to multiply the top by 3. So if I multiply this top by 3, that is going to give me 3 times 2x is 6x. 3 times a negative 2y is a negative 6y. 3 times a negative 6 is a negative 18. And then I'm just going to copy this over. And that just comes over for the ride here, and we line them up and we solve. So I'm going to draw a line under here. And if I add, I get 6x plus 6x equals 12x. Negative 6y plus a negative 6y is minus 6y, which is negative 12y. Okay, so here I pause because I'm seeing negative 6 plus a negative 6 is a negative 12y, and negative 18 plus negative 18 is going to be negative 36. Nothing is going to cancel. I need to change this and make this a negative so that it's opposite. Or I could subtract. Let's just do that. So I'm not going to add, I'm going to subtract, because if I subtract, I'm going to, I have these are equal. So if I subtract 6x minus 6x is 0. Negative 6y minus a negative 6y is 0. And negative 18 minus a negative 18 is 0. So I get 0 equals 0. So when I got to this point, I got down to a number where it was a number equal to a number, and 0 does equal 0. That is true. And therefore, we have infinite solutions. So let's go back and look at what it said in the core concepts. And it said right here, when you do not obtain a false equation, but obtain an identity such as 0 equals 0, the system has infinitely many solutions. So that's what happened here. Okay, so we are done when we get 0 equals 0. Okay, solving a real life problem. Okay, so here's an amphitheater map. Stage here, expensive A seats here, B seats here, and the El Cheapos, the lawn seats. There aren't seats, you sit on the ground. Okay, so anyway, an amphitheater charges $75 for each seat in section A. So I'm just going to make little notes as I go here. So section A, these tickets cost 75 bucks. In section B, I'll use blue because that's what the seat area is colored, $55 for a seat in section B. So these seats are 55 bucks. Okay. And it says there are 3 times as many seats in section B as there is A. So if there's 10 seats in A, there's 30 in B, 100 in A, there's 300 in B, and so on. All right. And it says the revenue from selling all 23,000 seats, there's the key right there. The maximum capacity of this amphitheater is 23,000. And the revenue they get when the house is full is $870,000. How many seats are in each section of the amphitheater? And a lot of times when looking at problems like this, it's difficult to find where to start, and you might think there's not enough information to answer this, but actually there is. So for starters, we need to assign variables. So let's make the number of seats in B our variable Y. Okay. So they're $55 a seat, and the variable is going to be Y. We're going to do the number of seats in section A, the expensive seats, we're going to call X. Okay, so these are X. So these are X, these are Y, and also we've been using X, Y, and Z, so the number of lawn seats is going to equal Z. So I will use green for the lawn, and these are Z. So we don't know how much the lawn seats are, but we know the price of the section A and the section B seats, and we know the maximum capacity, and we know the maximum dollar amount. So we want to set up a verbal equation first, as the book says. So we're going to take the number of seats in A, okay, the number in seats of A, and it says right here, and we need to highlight this, there are 3 times as many seats in B as there are in A. So what we're going to say is the number of seats A, X, plus, let me use black, plus, we're going to do 3 times. So there are 3 times as many seats in B as there are A. Okay, so the number of seats in B is 3 times A. Okay, there are 3 times as many seats in B as there are A. So we have to multiply A by 3 to equal B. Okay, so number of seats in B, Y equals, okay, let's not add yet. Okay, that's equivalent. The number of seats in B is equal to 3 times as many seats as A. Okay, so B equals 3 times A. That is from the highlighted. Then it says their revenue for selling all 23,000 seats. So now we know there's 23,000 seats. So what we're going to do is we're going to take the number of seats in A plus the number of seats in B which is Y, plus the number of seats in the lawn, which is Z, and those are going to equal total number of seats. Okay, so let's recap what we've done so far. We have the number of seats in A plus number of seats in B plus lawn seats, Z, equals total. So X plus Y plus Z equals T. All right, and we're still doing the verbal. We're going to need two equations. Total number of seats equaling 23,000 and total revenue equaling $870,000. So now we're going to do another equation. And remember, this is all just the verbal setup. We're going to take $75 times A, because each seat is $75. So 75 times the number of seats in A. All right. And we're going to add, and the seats in B are $55. So it's going to be 55 times the number of seats in B. Okay. Plus $30 for each lawn seat. Okay, right here, $30 for each lawn seat. I forgot to write that over here. These are 30 bucks. So it's going to be 30 times number of seats in Z. Okay, so now we have 75 times the number of seats in A plus 55 times the number of seats in B plus 30 times the number of seats in Z, and that is going to equal the total number, or the total cost. Okay, so here it is. So now we have number of seats A plus number of seats B, number of seats in the lawn equals the total number of seats, $75 per seat in A plus $55 per seat in B plus $30 per seat in the lawn equals total revenue. Now that we have all that set up in a verbal, now we're just going to substitute in all of our givens. Okay, so number of seats in A, which is X, is going to just give us X plus Y plus Z equals total number of seats, 23,000. So there is one equation in terms of X, Y, and Z. The other equation that we know is Y equals 3X. Okay, so let me move this one down. All right, we also have Y equals 3X. Let me not spread that out. Y equals 3X. Okay, that is this equation here. So actually, I should have this moved up to our three equations. Okay, and let me erase this. All right, Y equals 3X. Y equals 3X. X plus Y plus Z equals total number of seats, 23,000. And then finally, 75X plus 55Y plus 30Z equals total revenue, $870,000. Okay, so now there is the verbal, there is the algebraic, and now we solve the system. So if Y equals 3X, I can substitute in the 3X into that equation. So I'm going to copy this equation down. And we're going to work with this. So we have X plus Y plus Z equals 23,000 And we know that y equals 3x. So I can take this y equals 3x and substitute in for y. X plus y equals 3x, so I can change that, plus z equals 23,000. That's going to combine to be 4x plus z equals 23,000. Okay, that's the first step. So once I do that, then I take the other equation, which is right here, and substitute in my y. Here. So I'm going to get 75x plus 55 times 3x plus 30z equals 870. Whoops. $870,000. 75x plus 3 times 5 is 15, carry the 1. 3 times 5 is 15, plus that carried 1 is 165x plus 30z equals 870,000. Now 75x, 5 plus 5 is 10, carry the 1. 5 plus, or 7 plus 6 is 13, plus 1 is 14, carry the 1. 1 plus 1 is 2. 240x plus 30z equals 870,000. Okay, so now we have two equations in terms of x and z. So now we can manipulate those two. So let me just extend this page. All right, so now we are going to take this equation here. Actually, let me just rewrite it. We're going to take, let me change colors. We're going to use 4x plus z equals 23,000. We're going to take 240x plus 30z equals 870,000. And I want to get these something to cancel here. And we don't want to use really big numbers. So if I look at z, I have 1z here, I have 30z here. So I am going to multiply this by 30. And that is going to yield 30 times 4x is 120x. 30 times 1z is 30z. 30 times 23,000 is, there's a 0 from the 30. 3 times 0 is 0. 3 times 0 is 0. 3 times 0 is 0. 3 times 3 is 9. And 3 times 2 is 6. So I get 690,000. This is not going to change. 240x plus 30z equals 870,000. Let me rewrite that. Messy. 870,000. So these are the same now. So I'm going to subtract. 120x minus 240x is negative 120x. 30 minus 30 is 0. 690,000 minus 870,000. Let me do it the other way around to get it. It's easier. 8, 1. So it's going to be 180,000. But the bigger number was, we're subtracting a bigger from a smaller, so it's going to be negative. And then I divide by 120 on both sides. So x is going to equal, so this 0 will cancel with that 0. So there's going to be 0, 0, 0. And actually, let me just do it with a calculator. Okay. Hey Siri, what's 180,000 divided by 120?
180,000 divided by 120 is 1,500.
Okay, so when I do that, I get x equals 1,500. So there are 1,500 seats in A. A is x. So what is the question asking? How many seats are in each section of the amphitheater? So in other words, we want to know what x, y, and z are. So x equals, y equals, and z equals. X is 1,500. Okay. Y equals 3x. So then I can say y equals 3x. So y equals 3 times 1,500. So y equals 4,500 seats. Okay. And then to find z, we can use our x plus y plus z equals total number of seats. Okay, there is a total of 23,000 seats, and we have an equation x plus y plus z equals 23,000. So now I say x plus y plus z equals 23,000 seats. X is 1,500 plus y is 4,500 plus z, which is the lawn seats, equals a total of 23,000 seats. 1,500 plus 4,500 is 6,000 plus z equals 23,000. Subtract 6,000 from both sides. And I'm going to get z equals 17,000. So my answer is 1,500. And I'm going to do a different type of comma here so you're not confusing it with commas between 3 digits in a number. The next one is going to be 4,500, comma, 17,000. So there's the answer if you wrote them all out. These are commas, but I don't like to write commas when I have numbers that are so big, because then you think that it's X, Y, Z, A, B, C, whatever. Anyway, there are 1,500 seats in section A, 4,500 seats in section B, 17,000 lawn seats. Okay, that brings us to the end of chapter 1.4. The exercise for my class is to do problem numbers 3 through 18. Have a great day.